Hello everyone. In this video, we will see how do we find the area bounded by a curve, in particular the curve y equal to fx x-axis in the interval a to b. Okay, so what will be given to you? The curve y equal to fx will be given to you. You have to find the area bounded by the curve y equal fx x-axis and the ordinates x equal to a to x equal to b. So it will be like this. This is your curve y equal to fx. This is x equal to a and this is x equal to b. So you have to find this area, this shaded region, this all area. So the formula to find this area is a is equal to integral a to b y dx. So what we have to do is substitute the value of y as fx and then integrate with respect to x. Okay, so let's take the example. Suppose you have to find the area under the curve y equal to x square plus 3x plus 2 x-axis and from x equal to 0 to x equal to 2. Okay, so what you see from this figure that this is the curve, this is your curve, and this curve is not intersecting the x-axis at any point between a to b. Okay, and this is above x-axis, the curve is above x-axis, then only the area is given by this. Okay, there are other situations where your curve, if suppose this is your x-axis, this is your y-axis, your curve is somewhere here and this is x equal to a, x equal to b. This is the area, means area is below the x-axis. In this case, what you are going to do, you are going to use the same formula, but you will use mod of a. As area cannot be negative, you find the absolute value of this area. Means if answer is in negative, you take the positive value of it to find the area. Other thing happen is that the possibility that this is your x-axis, this is your curve y equal to fx, and your curve is like this. Okay, this is the point x equal to a, and this is the point x equal to b. So in this case, the area will be divided into two parts. First is this region, we call it as A1, and this is A2. So in this case, the area will be the sum of areas A1 and A2. But as you see, area A1 lies above the x-axis. This is positive. So you take the positive value. Whereas the area A2 is lie below the x-axis, which is negative. And as I said, we cannot have the negative area. So in this case, it is similar to this. So you have to take modulus of the second area. Okay. And this point where the function is intersecting the x-axis, let's say the point will be C. So how you find this point? You will find this point by substituting the value of y equal to 0. Okay. So let's see with the help of example how to work under these three cases. So if you have y equal to x square plus 3x plus 2 and x is from 0 to 2. So by the rule, area is integral a to b y dx. Okay. So this is your a, this is your b, and this is your function y. So your formula become integral 0 to 2 x square plus 3x plus 2 dx. Okay, before moving forward, we have to check whether this function, this is your curve, is having a point C. Means, is it intersecting x-axis in between or not? So for that, what you will do, you substitute your function as 0. Okay, so it means you get x squared plus 3x plus 2 equals 0. Solving this quadratic equation, you get the value of x as minus 1 and minus 2. What is your interval of integration? It is from 0 to 2. Does any of these point -1 or -2 lie in between? No, it doesn't lie. So it means this curve is not intersecting in between 0 to 2. So this is your area. Now, still you have to check whether your function, this y, is positive or negative between these two. So what you will do in between these two, select any point, say 1. So say x is equal to 1. At this point, check what is the value of y. 3x plus 2. So what you are getting? 1 square plus 3 into 1 plus 2. So what you will get? 1 plus 3 is 4, 4 plus 2, 6. So the value is positive. So it means at 1, the value will be somewhere up. So it's like if you have this as x-axis, this is y-axis, this is 1, 2. So the value is 6, 2, 4, 6. So it's here. So your value is positive. So it means you don't need to take the mod. So you'll use this integral only. So now it's a definite integral. Integrate it. X power 3 over 3, 3x square over 2 plus 2x. And limits for x from 0 to 2. Replace all the x one time by 2 and then by 0. You will get your final answer. So you get on substitution at x equal to 2 this term and at x equal to 0 this term. So this all becomes 0. Okay, and when you solve this one, you will get your answer as 38 over 3. You can solve it by calculator and get the answer in decimal. Okay, let's move to the next question. Find the area under the curve y is equal to x squared minus x, x-axis and x is from 0 to 4. So, as usual, we write the formula. Area is integral a to b. This is your a, this is your b. So, 0 to 4. This is your function. Minus x squared plus x dx. Okay. So, again, you have to check whether it is case 1, case 2 or case 3. Your area is whether it intersects the x-axis or your area is above or below the x-axis. So for that, first thing you are going to do is substitute this y equals 0. That gives you minus x squared plus x equals 0. When you solve it, what you will get? X. So what values of x you will get here? X equal to 0 and x equal to 1. Okay, let's check what is your interval of integration 0 to 4 and x equal to 1 lies in between. So yes, it is of this kind. So let's work on it. So we have the interval 0 to 4 and 1 point lie in between. Okay, so x equal to 1 say here. So it lies in between. So it means at this point the function is becoming 0. So what you are going to do in this case is divide this integral into two parts. So your integral will become integral 0 to 1 minus x squared plus x dx plus integral 1 to 4 minus x squared plus x dx. Okay, so it's divided into two areas. So now you have to check whether what is the value of the function. Is it positive or negative in 0 to 1 and 1 to 4? So for that, let's take any point in between, say half. So check the value of y at half. So when y is like minus half square plus half. So how much it is? Minus 1 by 4 plus 1 by 4. This gives you 1 by 4. So it is positive. Okay. And if we take a point in between, say let's 2. So at x equal to 2. Let's see what the value of y will be. Y will be minus 2 square plus 2. So this is minus 4 plus 2, that is minus 2, negative. So here it will be negative. So it means your curve will be going something like positive to negative. Okay, so this is your area. This area A1 will be positive, area A2 is negative. So what you will be doing, if this is your A1, this is your A2, you will be using modulus for A2 because that value is negative. Okay, so let's integrate them. Let's do it one by one. Area A1, which is 0 to 1, minus x square plus x dx. Integration is minus x cube over 3 plus x square over 2. X varies from 0 to 1. At lower limit, it becomes 0. At upper limit, the value will be, yes, minus 1 by 3 plus 1 by 2. So when you simplify it, you will get it 1 over 6. You can use calculator at this point. Now, A2 is the integral, exactly the same integral, but the limits are different. Minus x square plus x dx, which is again, you can use the same value from here. Minus x cube over 3 plus x square over 2 from 1 to 4. When you simplify it after substituting the limits, you will get minus 81 over 6. Okay, it's a negative value. So your area will be A1 plus mod of A2, which is 1 over 6 plus mod of minus 81 over 6. That is 1 over 6 plus 81 over 6. That gives you 82 over 6. Okay, so this is your area. Let's take another example. So here you have to find the area under the curve y equal to minus x minus 4, x-axis and x is from 1 to 3. So doing in the same way, this is a, this is b, this is your function. So the area will be a equal integral a to b, that is 1 to 2 minus x minus 4 dx. So again we'll do the same thing. First we check if the function becomes 0 in between 1 to 3 or not. So we do this by keeping y equal to 0. So this gives minus x minus 4 equal to 0, which gives you x is equal to minus 4, which is not in the interval 1 to 2. Other thing that we have to do is check the value of the function is positive or negative in this interval. So let's take a point in between, say 1, 2, 3. Okay, say this is 2. So we check the value of the function at point 2. At x equal to 2, y, which is minus x minus 4, become minus 2 minus 4, that is minus 6. So it will be somewhere down. So the curve will be something like this. This is the area below x-axis. So what we have to do in this case, we have to take mod of the area. Okay, so let's solve this. So this gives you minus x square over 2 minus 4x from 1 to 2. Okay, means your area will be, yeah, substituting the value minus 4 over 2 minus 4 into 2 and then minus of minus half minus 4. So when you complete this, you will get the answer as minus 11 over 2. And since the area is negative, our required area will be mod of A, which is mod of minus 11 over 2, which is 11 over 2. Okay. What is the other scenario in this is they'll give you the curve, say x as a function of y, and they ask what is the area between this curve x equal to g of y, y-axis, and so in this case the formula will be same, just in place of y will replace x. The limits will be same a to b and x, it will be just x dy because the value of x is given. In visualization, you can see that if this is your x-axis, this is your y-axis, this is your curve x is equal to, say, g of y. So, this is the area that we are finding out. Okay. So, again, here the possibility is the area may lie on the right side of the x-axis, on the y-axis, or it may lie on the left side. This may be your area. Or again, the third case may be like it lie partially left, partially right. So you'll have two areas which is on both sides. So what we are going to do in this case is when it is on right side, it is positive. When it is on the left side, this is your x-axis, this is your y-axis. So in this case, we use the mod. And if it is on both sides, A1 will be like we divide it into two parts, similar to the previous case. We take the value of A1 to be mod and A2 as it is. Okay, let's do one question to understand. So suppose your given curve is x is equal to y square minus 1, y-axis, y from 2 to 3. So in this case, your area will be, since the value of x is given, A to B, this is your A and B, x dy. This is the rule. So this gives you 2 to 3 y square minus 1 dy. Okay. Now rest of the things are same. So check if it is like y square minus 1 equal to 0 gives you any value between 2 to 3 where y is 0. No, we get plus 1 or minus 1. None of the value lie between 2 to 3. So you have this as x-axis. This is y-axis. Okay. So what you will get? You have to find from say 1, 2, 3. So say 2 to 3 in between. Say y equal to 2, y equal to 3. So you have to check now the value of this function is on the right side or left side. So let's take a point in between, say 2.5. So at y is equal to 2.5. Check what the value of x will be. Is it positive or negative? So it will be 2.5 square minus 1. So definitely it is positive. So your curve is on this side. So your area will be same. You don't have to take the modulus. So then just integrate. Integration of y square is y cube over 3 minus y. Limits are from 2 to 3. Substituting the limits, you will get. So this gives you the final answer as 16 over 3. You may write the answer in the decimal form. Okay. So the concept is similar to what we did for y equal to fx. Just you need to identify accordingly.